Hi everyone, thank you for coming to the IOSG GPU Compute panel.
Sure.
My name is Eva. I am the head of investments at Caladan. We're a market maker based in Singapore. Today we have a panel of very experienced folks in the decentralized compute space, and we'd love to first start off maybe making a quick intro. Maybe Ben can skip.
Sure, yeah, I think everyone's heard from me.
Yes.
Okay, then I'll start. Hi everyone, I'm Jasper. I'm the CEO and co-founder of Hyperbolic. I did my math PhD at University of California, Berkeley in math. I finished in 2 years, which makes me the fastest person to finish a PhD in the history of Berkeley when I was 24 years old. It also gave me the idea of the name of my future company, Hyperbolic, because I was doing topology and hyperbolic geometry. Before that, I graduated from Peking University with the highest honor, Student of the Year. I also won a few gold medals in various mathematical competitions. After graduation, I work at Cedar Securities and also Apple Labs, the company that built Caladan's blockchain, and Matt's Shiv there as well. After that, I founded Hyperbolic Labs. So at Hyperbolic, we're building a decentralized AI cloud to enable open access to AI. We think AI is the most powerful tools known to mankind, and in the future, AI will be integrated with the most important important systems like transportation, social media, finance, even your brains. So right now in the centralized setting, we don't actually have the control to design the direction of the AI, and let alone you have the chance to participate in the revenue sharing opportunities. So the ultimate vision of Hyperbolic is that we want to build with the partners together to have an open AI ecosystem and economy where AI infrastructure, services, models are accessible, governed, contributed, and benefit all of you.
My name is Osuri. I'm the CEO for Overclock Labs and core contributor to Akash Network. Akash is the world's first decentralized supercloud, and the core essence of a supercloud is where you can decoupling the control plane from the resource plane, where the resource plane can consist of any cloud-capable compute and orchestrated in a decentralized and open manner. Background, being a open source developer for most of my life, core contributor to Kubernetes and Docker prior to Akash. A lot of the code I wrote today is used by NVIDIA, by Amazon Web Services, Department of Defense, and a whole lot. And prior to Akash, founded a company called AngelHack, helped launch several companies at AngelHack. A big one would be Firebase. Firebase eventually got acquired by Google, became Google Cloud Database. Today, Akash Network is a permissionless network and serving all the way from big users, being the biggest user being NVIDIA, integrated directly into NVIDIA products, to several decentralized AI protocols, Venice AI being one of the bigger users in the decentralized space. And also, I got a doctorate without going to college, so I did faster. They gave it to me.
Hi folks, my name is Shiv. I think I have a doctorate. I actually went to university here in Singapore. It's a bit of a homecoming for me. I went to the US. I got my degree in computer science. Also I have a degree in economics, not that useful. I work at, I'm VP of engineering at RISC. Unlike everyone else here, not an AI company, we're into zero knowledge cryptography, which we generally believe is going to also drive up usage on GPUs and computing. It's something that we're very invested in as well. What we do with RISC is build the world's fastest ZK VM, which allows you to bring ZK to your applications, ZK applications, and take compute off-chain, which is how you actually scale. When you think about getting more users on-chain, distributed applications aren't rich enough. So it's actually you make applications rich, given that there's so many compute that you can access on that chain. Have to go on chain, have to do it in a verifiable way. That's what we do. Some more background, I worked at Amazon, Microsoft, Lyft, Grab. I don't know if you're using Grab here. I did a bit of traffic, but still out there most of the time. My career, Coinbase, Labs, and RISC.
Great. Hey everybody, I'm Trevor. I'm not a PhD, which is, puts me out here, only a postgrad. I have a history in scaling millions of users across the globe, and really I'm focused on consumer experiences. at the Render Network, really, we're a network by creators for creators, originally formed to help render movies faster and in a more affordable manner. And that's only grown as the network has evolved. And today we do not only render jobs, but rendering and AI jobs on thousands of consumer GPUs in parallel at a fraction of the time it costs.
Great. So I think I've been to a lot of panels, and I think sometimes if we go through the entire panelist, like the question and answer gets very long. So today I'm going to change it up a little bit. I'm going to pick maybe 2 people to answer one question, and we can speed up a lot faster. So I think this question is probably best answered by Jasper and Greg. Wanted to ask you about what do you think the killer features are for decentralized compute compared to centralized compute? Is it price? Is it decentralization? What do you think?
Yeah, so distribution of supply, right? There is enormous amount of supply all the way in data centers, but also in homes, in devices, in appliances. We haven't touched even close to what we can touch when you have truly decentralized systems because of several challenges, right? Obviously, the big challenge is how useful are these devices and how useful is this compute. In order for us to leverage these devices, we need distributed training and distributed inference, which is getting solved. But I think when you have a truly permissionless, truly trustless system, that means you need verifiability as well to access this compute. It's limitless, right? Pretty much because every device has a downtime. For example, the gaming console in my house is used maybe once a year, and it's got really powerful chips. In fact, there was a experiment by U.S. Air Force, I believe, that connected 1,000 PS3s or PS2s, I don't remember, and created a supercomputer just based on PlayStations, right? So yes, we do have a lot of compute at home that's very usable, but we haven't quite cracked the code and distributed training and inference, or that can leverage various set of devices.
Yeah, so I would say that what Greg touched is like the aggregation of resources and permissions to join and access the compute. I think that will be very helpful for like reducing the cost. Then more and more people have access to the compute without actually getting approval by centralized data centers. And then in the long run, if we believe AGI will come, then how do we detect whether this AGI is rogue or actually is benign? And I think that also requires us to have this permissionless network with a verification layer on top to verify that at each step of the AI pipeline, from data collection, from compute, to chaining, to inference, every step we need more transparency and verification. And all of this will rely on the permissionless GPU network that be by Hyperbolic, Akash, and other players.
Got it. So I guess the next question, wanted to ask Ben and Shiv. So we know, I think decentralized compute has a lot of advantages over centralized ones. But how do we address the question of security and privacy? What are the ways that you're seeing that decentralized solutions like yourselves are tackling these 2 problems?
Yeah, I mean, to be honest, that really is the thesis of zero knowledge as well, right? Like the idea that you can run something anywhere and prove that this is exactly what you ran, secure cryptographically with mathematics rather than any sort of process solution, is the whole promise of zero knowledge. I think if you spoke to me 4 years ago, just me, not even in America, I would have said, oh yeah, that's a thing that they teach in college. In fact, I remember taking a verifiable computation course because it was an easy B+. I just wanted to gather your time. You read papers and it's all sorts of nonsense. But to be honest, I wish I paid more attention because the field here is growing so quickly. Blockchain ultimately is funding most of this research. It's not because they are in dire need of this capability of taking applications, running them off-chain, just writing results back on-chain. And this zero specifically we actually focus on commodity hardware. Like since day one, we knew that like if we try to build something that is like super specific, needs like a gigantic machine, like 128 cores, like terabytes of RAM, and all that. Like it's like 5 people who get access to that. We want commodity hardware. That's how we sort of like scale up these kind of things, right? Like that is the promise of zero knowledge. That preserves security. Like it doesn't matter. Like the big thing is like, oh, like you can't have data center. A lot of countries are regulating, saying like, oh, all computation needs to happen here, all data needs to sit here. You could free up computation for sure if you know exactly what goes in and what comes out, and it's cryptographically secure. You could run it, you know, in your home using an Xbox maybe, or somewhere else. Like it really doesn't matter. It actually democratizes computing.
Yeah, I think from our side, when you think about privacy, so my startup before Gensyn was a privacy startup. It was specifically around data sovereignty to the individual. And kind of one of the biggest things I learned doing that was that everyone will tell you they care about privacy, but if you put any kind of barrier in front of somebody to enable privacy, they won't go through that barrier, basically. They'll still use the thing that isn't privacy preserving. And that kind of feeds into the sort of way we think about privacy, which is it's not a product in itself, it's a core technology that can be applied when it's efficient enough to create better kind of outcomes for the consumer and better systems that are acceptable to businesses and things like that. But at the end of the day, it is just a technology, and it's been held back by, I think, by a lot of people either trying to apply it purely as a product and then realizing that this just doesn't sell on its own because it's a value add to something else, it's not the kind of base thing, or looking at it and saying, well, it's not efficient enough now, so it never will be, so we kind of won't invest in it. And as Shiv mentioned, I think the crypto space itself has driven that investment, where the kind of more centralized space has known about the technology for a very long time. At the end of the day, like the mathematics behind it, a lot of them aren't particularly new. Like we've known about these techniques, we just haven't put in the engineering work, and it typically is engineering work, to actually make them efficient enough to apply them, because people can't see how to kind of productize it, because it isn't a product, because it sits behind things. So I think what we'll see is gradually through time, services just baking these technologies in as and when it makes sense. And we need people working on the core technology itself to just make it more efficient. The kind of business model you wrap around that is very difficult, because at the end of the day, like, you can't just sell a new efficient technology. You need to have some kind of reason why you've sort of productized it. And the protocol model is quite interesting there. If you can turn it into a decentralized protocol and you can outsource the actual computational work that's happening within it, you can now build a business on top of what is just fundamentally open source kind of progress, which is really interesting and is a new thing for the crypto space. But yeah, I'd bring us back to that very specifically. All privacy technologies to us are kind of technological advancements that need to be applied deep within the kind of infrastructure that we're building. They're not products. And so if you think about them as products, you're kind of thinking about it in the wrong way. It's not going to be a thing that we sell. It's going to be something that just improves the tech that we build.
If I could just echo that a little bit more, we also had like an announcement yesterday, like exactly that. Boundless, so we want to put it out. But that's essentially it. We want to build that as a full stack for people to just get started. I mean, this is maybe like a spicy take, but like I would say like zero knowledge is to blockchain, as blockchain is to like regular development. There is a little bit of a knowledge curve that we need to go over. And we want to take some of that, abstract all that away, and generally go towards like a sort of like a marketplace solution as well, where we farm out the compute essentially and try to cost down and so on.
There's an interesting bit here, sorry to keep going, but like we kind of operate as two sides of the market in a way. Like the way we design Gensyn is specifically with a view to applying privacy technologies in the future when they're ready. We don't build them ourselves, we just kind of design it assuming certain ways that they will interact and then wait for somebody else to build them. So we're kind of the ultimate user of those technologies. We don't want to do it ourselves, but we think it will happen. We design things from first principles to make sure that we support it when it does happen.
My next question is for Trevor. So you talked about, getting a lot of users on board. Your specialty is scaling the platform that you're building. So I think if we look back over the last few years, gaming has brought a lot of users to crypto, and I think AI is largely seen as the next wave that will bring millions of users. What are you guys doing on the render side that's differentiative enough to attract more users to AI? To crypto.
So I think the way we think about it that's very different is we start with the creator mindset. And where we focus in on AI or any of these types of tools is how they overlap with that use case. So, we've been doing rendering forever. We actually, in the process of doing a render, do something called denoising at the end, which is actually AI. So it's always been part and parcel of what we do. And when we look at how we believe this will scale, we honestly believe that there will be a convergence between the two, and it will be very different, very difficult to tell whether something was rendered or whether AI actually produced it. So we're focused on really the user of the products, their creator, and how they're going to use it, as opposed to what the process is in between those, because both of those will use a GPU. And really for us, as these interfaces get simpler and simpler, our goal is to onboard the Adobe generation now who use Photoshop regularly but aren't quite 3D artists. And then beyond that is the TikTok or user-generated content group who produce mass content. As these tools become more and more simple and really leverage different approaches and models, I think you'll see just the wave of users being able to use them in a way that they cannot today. So really that's our focus, is stay focused on the end user, the creator, and really solve for their needs without actually focusing on the core underlying technology that drives it.
I want to echo with that. So we also have the mindset to be very user-friendly and try to see like what actually developers and users want. And that's the reason why when we build our GPU network and also the AI inference service, we try to make it compatible with the current interface that people use in Web 2. So for the inference side, we support most of the state-of-the-art open source models, and we have this OpenAI compatible API so that developers can easily migrate from their existing solutions to Hyperbolic. And then gradually, once we integrate with more and more crypto elements, like we're able to let AI developers to tokenize their AI models, and they can monetize by selling tokens. And that will bring more and more AI developers from Web 2 to Web 3, because right now, if you just upload a model on Hugging Face, which is a public AI GitHub style repo or website, then there's no way that you can monetize your models. But by adding the crypto elements into this ecosystem, then we are able to let AI developers to monetize their models without actually raising money from investors.
I would like to actually open, to the audience here, and I would like to see if anyone has any questions for our panelists today. If not, I have other questions. Cool. Hey, I wanted to ask about privacy. So how do you handle, or do you keep the data or the model weights private? And how do you generally approach privacy in a distributed compute context?
Happy to jump in from our perspective. We build Gensyn in a way that if you think about the machine learning operations that are happening, those operations could be happening over obfuscated or encrypted tensors just as well as they could over kind of plain text tensors. And so we don't build privacy text specifically, but we build in a way that allows it to happen. So you think about like functional encryption, for example. You can apply functional encryption within the training of a neural network. You can replace the first layer of the network with an encryption key, and then the rest of the training is homomorphic over kind of ciphertext. So you're able to train over encrypted data. There's loads of downsides to doing that, but it's possible. You can also do a small portion of the training or kind of the feature extraction on the user side, which is obfuscation, basically. You're already kind of taking the data and projecting it into parameter space before you've even sent it anywhere. So there's loads of techniques, but at the end of the day, from a compute kind of base protocol perspective, we just say, look, we're operating over tensors. Whatever those tensors contain is kind of up to you to an extent. So if you wanted to obfuscate, add differential privacy, encrypt, you can do all of those things. That's not necessarily possible if you design a verification system that like operates at a higher level. If you're not able to kind of verify a specific matrix multiplication that's happening or something, if you're verifying the sort of outputs of the network and whether they match something else, then actually you kind of are dependent on plain text to an extent. So it's quite core to what we do, but a lot of what we do is to make sure that we're just robust to privacy techniques, basically.
So Hyperbolic has this modular design. So we have the GPU network that orchestrates the global GPUs, and on top we allow people to build different services. And we're also building a modular privacy layer as well as verification layer. So for the privacy layer, we're exploring TEE, which is Trusted Execution Environment, with a few partners. And then once we, in the future, very soon, we'll allow user to spin up confidential VM on top of the GPUs, and then they can just run whatever services they want, for example, AI inference service. So in this way, the AI developers can protect the privacy of their data, and also privacy of the models, and also the users can be confident that their data won't be stolen by the developers or the node operators.
I got a bit on that too. So on the AI front, we use compute clients, and so it's really a question for many of our compute clients. But on the rhetoric side, it's really important to us because we have creators making Hollywood movies. We have people whose lifeblood is really through these processes. So for us, it was built in centrally from the start. We actually stream the work to the GPUs that isn't stored locally. And it's a very different architecture from, I think, most of the machine learning and AI, Docker container architectures you see here today. And that's really just because it's fundamentally important for us to protect those artists, those creators' core lifeblood, and not store it anywhere we don't need to.
Any other? I have a question about, as NVIDIA launches more and more newer generations of GPUs, how do you think that's going to change the supply and demand dynamics for GPU in general? Do you think it's going to be a race to the bottom, or the reason that there is a market for decentralized GPU is because GPU is expensive, right? So how do you think that will change over time?
Yeah, so we are already seeing a decline in NVIDIA's demand. I mean, especially as we start cracking, being able to deploy or infer on non-NVIDIA chips, right? So very heterogeneous deployments. So with MI350s from AMD, you're able to run Llama 3.1 and 405p pretty well, right? And we have new techniques. There's a company called Exo Labs, which seems very promising. They do inference on clustered inference on even Macs, right? So as we as the models are getting open sourced, and as we see a lot of optimizations happening for non-NVIDIA chips, I think the dominance of NVIDIA is going to gradually go down, right? But also, and considering MI350s have 120 gig memory, which is significantly higher than the 80 gig memory the NVIDIA chips provide. So there's actual advantage of running in non-NVIDIA chips. We're also seeing ASICs, right? So we saw Grok, which is extremely fast when it comes to inference. We are also seeing chips that are upcoming like Extropic, which is can't quite exactly tell you how it works, but it's very crazy. It's called thermodynamic computing. So we are seeing a lot of innovative new chips coming to the market, and I don't believe just two companies are working on it. There are several companies working on it. So to answer the question, as AI gets important, so I don't think NVIDIA is going to stay a dominant player in terms of hardware. I think it's going to get significantly diversified, and has to, right? Because we have one company that, I don't want to live in a digital feudalism where you have one digital lord giving us what we need. Today, getting chips is so hard. I mean, even the richest people in the world, Elon Musk is famously known for saying, getting GPUs is harder than getting drugs, even though that's a low bar in San Francisco. But it is real. It's very, very hard to get GPUs, right? So, yeah.
Yeah, I echo that as well. Also, it's a free market, right? So people are not going to sit by and be like, okay, NVIDIA, take the market. You are going to get competition. I actually, one interesting thing though is even though there's going to be diversification of products and whatnot, the spend is probably going to keep going up. People are going to keep buying more chips. the thing is you'll have like a variety of chips. ASICs are like a great point because ASICs are hard to build, take a lot of time, gestation period, all that stuff. But why are they building it? It's like, oh yeah, there's going to be some money here. So we're going to see a lot more of that coming. The amount of compute that is going to happen is probably going to like increase. ASICs are accelerators, they like, make everything go faster, but we are going to see more computation happen, more specialized computation happen for sure. Like I said earlier on as well, like zero knowledge cryptography is GPU hungry as well. We kind of like followed the coattails of like AI like drove the price down for us, and we're very thankful, and we do hope that like that continues to happen because it unlocks another door. It's like another door on security, privacy, like off-chain computations, opening more opportunities, and ASICs are also like a real thing for us as well. Like so, I actually, to answer your question, NVIDIA's dominance cannot be like consistent. We are going to see more players, but we are going to see way more adoption and slightly specialized use cases start here.
I think Gartner put out a report that said 5% of global GDP will be spent on AI by 2030. AI compute. I think they are pretty accurate on it. I mean, 5% of global GDP, that's quite a lot.
I think I'd just finally point people to Jevons paradox, which basically says, as the kind of base cost of a resource drastically decreases, demand increases to outstrip the previous demand that existed. So it kind of has this weird like slingshot effect where if you do drastically decrease the price, you end up in a almost like more constrained situation. And I think that's definitely true with machine learning, given how kind of powerful it is in changing all of the interactions that we have with knowledge and technology, basically. Like when I was talking earlier about this kind of like change to the base way that we as humans interact with stored knowledge. I think if you kind of extrapolate that out and say, well, if we can reduce all the cost of all the base resources to do it, we're highly likely to just keep doing it as much as we possibly can. So it's like almost runaway unlimited demand where, yes, bringing down the cost and kind of flooding the market with more chips that are able to do it is great, but that runaway demand is still going to be there. And so I think, like we've said here, I definitely believe that NVIDIA is going to get disrupted. I think their hold on the market now is down to CUDA more than it is down to their chips. And I think there's a lot of people, including ourselves, working on kind of releasing that a little bit. So we build a compiler stack that allows you to use more chips than just NVIDIA chips. So disintermediating CUDA and allowing people to just access more of the kind of base sort of things that are doing that refinement process that I mentioned earlier again. Like at the end of the day, the core resource behind all of this is electricity. We're converting electricity into MLOps or ZKOps, and we're using certain chips to do that, but we'll use the most efficient ones we can get. So once we standardize a bit further on the way that AI is done, we'll have a huge wave of ASICs that come in and do that more efficiently. Clearest thing to look at is what happened in the kind of Bitcoin mining market, basically. Look at what happened there over a decade and kind of extrapolate that to what's going to happen here. We think it's going to be very similar.
Great, yeah. Thank you so much, everyone, for sharing your insight. And I think that's like a great end to our discussion about disrupting NVIDIA's market dominance. And we're seeing more decentralized GPU providers. So great, thank you.